Thank you very much, Bukosi. Maybe let me just jump right into the slides. Okay, well, my name is Raesetje Sefala, and I'm currently a master's student at Wits University. However, I've just submitted my dissertation and I'm waiting to be examined. So I am currently a research assistant at the Center for Effective Global Action at UC Berkeley in California. I'm also part of the AI for Social group, for Social Good group at Mila in Montreal under Professor Joshua Bengio. Yeah, so I've participated in data science for social good and CSR's D-side. That's actually where I started. But then I'm also a co-organizer for the Deep Learning IndabaX, which was supposed to happen this year, and also co-organizer for Women in Computational Science Research, which aims to improve the number of women represented in computational science, the computational science field in South Africa mostly, and also improve the quality of work. Yeah, so that's just me in a nutshell. And today I'll be talking about creating ground truth data sets for machine learning. So I'll be especially focusing on satellite imagery. And this is more things that I wish someone told me before I started doing my master's work using satellite images. So to just start with basic concepts, what a data set is, this is a collection of data. It can be anything really. It can be a collection of images. It can be a collection of records. It can be a collection of numbers. It's just a collection of data, actually. And in machine learning, we often hear terms such as input data, output data, and yeah, so input data is the actual data that you want your machine learning model to sort of learn. So if you want your machine learning model to learn what a cat looks like or what a dog looks like, this is the data set that you sort of feed your machine learning model. It's called input data, and then there's output data. That's what you want your machine learning model to sort of predict. However, we also have data labels, which are like markings or annotations, which are sort of answers to your machine learning model. So this is, if it's a dog, you want, if the whole image is of a dog, you want your label to sort of say dog, so that you can actually expect that as an output. So there are different types of labels that you can make. You can either do sort of image classification, which is, let me just get a pointer. So image classification, which is sort of this first frame here. In this in this sort of setting, you're sort of saying a whole image, how do I classify it? So in this case, I would classify this entire image as of cat. Otherwise, I would localize, find where the cat is and sort of label it in that sense. And if there are more objects within the image frame, then you would say this particular one in this frame or a bounding box. These are called bounding boxes. So this particular one in this bounding box is called dog, and this is another dog, and then a cat. So you'd get your labels like that. Otherwise, if you're saying you don't want this background as label for dog, or cat, for example, then you would sort of segment it, find out where the cat is exactly, and sort of just cut that out and say, this is cat, maybe that is mountain, and that is the sky, and this is the ground. So each pixel value denotes a specific class. So if you're saying, I have multiple objects now in the image, then you would sort of say, okay, the red pixels denote cat. Sorry, the red pixels denote dog, but then there are multiple dogs in this image. And then now I'd say this is one instance of this labeled dog. This is another instance segmented out of labeled dog, and then a cat. So that is sort of instance segmentation. And the difference between semantic segmentation and instance segmentation is that with semantic segmentation, maybe these, the red and the green would have both been labeled as red, and then the cat maybe in blue. But then that would have been semantic segmentation. However, with instance segmentation, now you can say, here's an instance of this class dog, another instance of this class dog. So yeah, so that's sort of the difference between different types of labeling, usually in computer vision. So what a satellite is, so diving into our main concern for the day, what satellite images are, or what a satellite is. To start with, this is just an object which is intentionally placed in orbit, and it can do so, like it can, like the whole object can embody different things inside, including a camera, which can take satellite images, which are georeference representations of the world captured using the satellite. So different satellite images are captured by different satellite sensors. So in a sense, this is sort of the camera that takes the picture of the world. And there are different types of cameras out there. There are Spot, there's Landsat, which are sort of the popular ones. However, there's QuickBird and Worldview and yeah, different versions of these sensors as well. So what spatial resolution is, so during, like when you're dealing with satellite images, the quality of the, like sort of the resolution is what is very important, because it sort of defines how well you can see objects on the ground. So for example, so if we're talking about spatial resolutions, we're talking about like of the space on the ground, how many pixels sort of represent that space. So if we look at this illustration on the right, we can actually see that for this sort of block of space on the ground of house, if we're saying this is 30 meters by 30 meters, then if the spatial resolution of the satellite images, the image is represent 1 pixel on the satellite image represents 30 meters, then that would mean that this whole space on the ground on the satellite image, it'll just be blue, which is the house. So it will just get an average of these pixels, and then this would be the representation. So the whole house would be represented by this one big pixel, this 1 pixel in blue. So if it's 5 meters by 5, if each pixel represents 5 meters by 5 meters, then it's only that 5 meters. So we're counting those 5 meters, and then we're sort of just translating it back to this representation. So in a sense, we can see that if we have lower resolution in terms of if it's like 1 pixel is represented by 30 meters on the ground. If we have, like, the lower the resolution, the more fuzzy the picture would be. So if I have higher resolution, then that means I would sort of be able to, like, for the same space, I would be able to see that there's a house there. But then if I have low spatial resolution, then this whole space here would just be represented by one big block. So, so if we look at this one example from this sensor, worldview sensor, it's 0.3, it's 0.3 meters. Each pixel is 0.3 meters, which means that we can be able to see things like cars. These parking lots are clearly defined. But then looking at this, for example, maybe we might not be able to see like a car. Perhaps in that image, we might be able to see a bicycle or a motorbike. But then in this lower resolution, lower spatial resolution image, we might not be able to see something like a motorbike or a bicycle at all. So that's sort of how what a spatial resolution sort of represents. However, there are different sensors with different spatial resolutions. And the one that we saw previously, this one is worldview, and it's of higher resolution. And then this one is of a lower resolution. It's called QuickBird. And within these sensors themselves, sort of there's a period where they are sort of updated. So maybe you might have worldview 4 or worldview 3, which took images in 2013 or 2017, but then of lower resolution. And then now new technology has come out, worldview 4, and then it's of higher resolution. So yeah, so we also have another sensor called Landsat. These are like the more popular sensors out there, which has a spatial resolution of between 15 meters and 60 meters on the ground. And then usually the difference between all of these sensors is what they capture. So although Landsat is of this spatial resolution, it has a lot more bands that it captures. So it's not just RGB bands like, so this one is RGB and near infrared. This one is RGB plus near infrared plus panoramic, panchromatic. And then now this one captures a lot more bands, which means depending on what you want to use the satellite image for, you can see different things like shortwave, infrared, the thermal band, which sort of measures sort of the heat level between like represented, and yeah, so and the other bands as well. So yeah, so if you are dealing with satellite images, some of the most important questions to sort of ask, let's say maybe you're starting your journey and you're looking for satellite images. So this is sort of like a checklist on, like, you know, some of the more important concepts you need to understand before you even go out and look for satellite images. So you must know what formats that you want your satellite images in. It might be GeoTIFFs, it might be JPEG 2000s or SIDs. The difference really is usually the libraries. For me, what I found is, if I like for GeoTIFF, there's more support from Python libraries to sort of process the images, rather than JPEG 2000s. Usually, yeah, the difference is not in the quality or the resolution for storage, but it's just which libraries can be able to sort of process your images as is. But then it's not the end of the world. If you have your satellite images in JPEG 2000, you can convert them back to GeoTIFF. or convert them to GeoTIFF using Python libraries or just remote sensing libraries like GDAL, which do that very well. So if you should be asking about coverage as well, like the amount of space the satellite image sort of covers. I mean, if you're saying you want to look at X in Johannesburg, you must be able to say that I want satellite images which cover Johannesburg. That is very important. And another important thing is the time in which the image was captured. So satellite images, like we started getting the first satellite images in around 1959 all the way to 2020. So if you're saying that you are trying to build a spatial data set, which includes satellite images, you must be able to pinpoint at which point in time those images come from. If you want to look at COVID-related things, for example, getting satellite images from 2012 might not be very useful because maybe some buildings hadn't been built at that time, and maybe no settlement was at that particular space that you're looking at. So things might not make sense if there was activity at that space and you are looking at images from 2012, which denote that there's no settlement at that space. That might be a bit confusing. So you might also look for this, the sensor type. So different vendors sort of sell satellite imagery, and you must be able to know which sensor, from which sensor the satellite images come from, mainly because they offer different things. Like I showed you, you might get different bands in certain sensors. You might also get different resolutions in other sensors. So one thing to note is the size per image of the satellite image, mainly for storage purposes, because yeah, they span a huge space, and they also carry geographical information inside. So the images can be very big, like this one that you're seeing here at the bottom. This is an image, satellite image of Johannesburg in South Africa. And here at the bottom, here at the top is the township Tembisa, and it's just represented by this small section here in the satellite image. So they do actually span huge areas on the ground, and storage can be an issue. So you must just sort of take note of that. Yeah, so we spoke about resolution and the image bands. This is very important. If you are just looking if you're just looking for the RGB values, the red, green, blue values of satellite images, and you don't really care about like the infrared or the other bands, like the heat and things like that, you have to be able to specify that to whoever is going to be giving you the satellite images. So for that point on the time, it's very important. This just illustrates how that the township Tembisa that I showed you in that small bubble sort of just changed over time from 1984. So you can see that in 1984, there's nothing here. But then as time goes on, there's growth of the township as well. So another thing is like the more cheaper satellite images they won't cater for things such as cloud coverage and things like that. That is another important thing to sort of note, that when you're getting satellite images, please evaluate them. Get a sample, just look at random ones first and see how much cloud coverage there is, especially if you are looking at those satellite images for problems such as like looking within a year, maybe those captured in January, February, March, going forward like that. Those can have a lot of clouds covering a lot of the pixels, especially in like, cloudy months. So that's another thing to sort of look into, because it can be a bit difficult to sort of remove those clouds. I mean, if you're removing the clouds, if you think about it as well, you are essentially, it's just those, you are removing those pixels, and how do you sort of replace those pixels which you have removed? Although there's a couple of techniques on cloud, like removing clouds from images, you can also look into things like replacing the images that you've removed with maybe pixels from a later month or an earlier month. And yeah, so it's a very difficult task itself to remove clouds. So that's one thing that you need to take note of as well. So if you're looking at remote sensing datasets for machine learning, these are sort of like basic concepts that I'd like to cover as we are going to move forward with this. So there's a concept called vector data. So this just tells you, this is just a data set of points or lines, polygons, and it can be stored in different formats, including shapefiles. So shapefiles are like the more popular version of storing this kind of data set. It can be stored in KML or other vector data formats, really. So for the types of labels, when you're dealing with satellite images, I like to think about it in two forms. So you can either do land use classification or look for specific objects to sort of classify. So for land use classification, this can be a classification of buildings, of roads, of maybe water bodies and things like that, which you typically find on the land. Or otherwise, you might be looking for specific objects like cars, maybe, or solar panels, or yeah, like other things which maybe are not usually there, but then now that they're there. Yeah, like, cars move all the time, and you can't really say it's part of land use. So yeah, that's just sort of how I like to think about it. And depending on how you think about it, you sort of you can get different labeling techniques for labeling all of your data sets. So when you're looking at, you can either use shapefiles to sort of label your data set. So given a satellite image in frame A, you can either use polygons to sort of label different parts. So the yellow part in this case. So this is from this data set. These are data sets from my master's work. And yeah, so I was labeling neighborhoods. So the blue part here, these are like more wealthy neighborhoods. These are small holdings. And then the yellow part, these are like townships. Then the light blue parts are in industrial areas, and then the red parts are informal settlement. So these are polygons just denoting sections of the land from the census, from Stats SA. So you can also either have points. So this data set in the section C just denotes where the buildings are in this satellite frame. So the more dense part, this is the township, because they are usually denoted by small plots of land and very densely populated, versus more wealthy neighborhoods, which are sort of sparsely populated. So depending on what kind of labels you're looking for, then you will have these different types of shapefiles representing the same thing. Otherwise, this is this is the cadastral data set from the Department of Rural Development, I think, where they so each polygon sort of shows you the exact plot of land owned. So the more wealthy neighborhoods will have bigger plots of land versus the small plots of land, densely populated township neighborhoods. So yeah, so depending on what you want to use the data set for, different data sets can be used for different things. For example, this polygon data set can be used for maybe for neighborhood classification. However, this point data set can just be used to count the number of houses in each neighborhood. So for things like ESCOM, if they're trying to figure out how to invest or how much to invest in maybe replacing cables, they might maybe weigh it by the number of people who are living in that area and then prioritize according to that. But then it depends on the type of problem that you're trying to solve. So some pros for using shapefiles is that they are cheap and they are fast if you're trying to label satellite images. I mean, the common factor between shapefiles and satellite images is the geographic referencing. So I know that latitude, longitude, this is over here. And then I can just easily find it and overlay it on top. And they're easy to manipulate as well, in the sense that if I don't want the blue section, it's easy to just take it out. If I don't want the red section, it's easy to just take it out. And then label your images accordingly. So some of the cons are that these data sets are usually expensive to curate and not easy to find. So these ones are from 2011. So this particular one here in B, this is from 2011. And if I'm looking for this kind of data set, which covers the entire country in 2020, it might be very difficult to and expensive to create, because I'd have to do it from scratch. This was done by Statistic as part of the 2011 census. So getting a more updated version is not easy to find. Otherwise, it's expensive to create. So yeah, usually they are outdated and you are looking at estimating if you're saying, if now the Tembisa, for example, has a new extension, or maybe another neighborhood, a section of another neighborhood has been made part of Tembisa. Like I think Centurion has been extended. So maybe this data set wouldn't cover that new extension of Centurion, for example. And you might have to find a way to update it. Although there are companies which are selling this kind of data set. But then, yeah, those are some of the pros and cons for using shapefiles. So you can also label using color bands on satellite images. For example, the water bodies are denoted in the deep blue. And then the vegetation is denoted in green, and maybe these are the rocks, or these are the settlements. Maybe these are rocks. So this can be very cheap to do, and maybe a fast labeling process, but maybe not so accurate, because it's not just like a single color that covers the vegetation, or a single color that covers the water. It's usually like a range. So if you see this section, for example, this is like a light form of green, and this is more a dark green. Maybe you might have to look at color ranges. Maybe green as RGB 0 to 55, 0. You might have to look at 154, 0, maybe 154, 154, 154, all the way to 0 to 55, 0, something like that. So it can be very difficult to label your images according to that. especially if you're doing machine learning tasks, which sort of depend on labels being, like if you're doing classification, which sort of depends on labels being sort of discrete, a discrete form of data set. So yeah, another labeling technique could be to use algorithms. So before the hype on machine learning, there was a hype on computer vision, which sort of allowed us to look at images and find things like lines and things like that. You might look into using algorithms which help you find lines and then label accordingly. So one sort of two pros to this is that it's very cheap and it's easy to manipulate. But then otherwise, big cons include a very big room for error. I mean, if you're using methods like this, it's easy that maybe your algorithm is sensitive to anything that looks like a line, which might include these ones here, food paths and things like that, or like, not covering the entire road all the way. So it might be a bit difficult to sort of evaluate your labeling technique, because usually satellite images cover huge areas and you might need to pay people to sort of help you evaluate, which might end up being very expensive at the end. And it takes a lot of iterations. Sometimes you look for lines which are big, and then maybe you might tune your model or your algorithm to sort of be more sensitive to smaller lines or lines which sort of look like they're fading, like this one. But then, yeah, it might take a lot of iterations and very like a number of parameters to tune.
Oh, hi Raesetje. Just a 5-minute warning.
Okay, cool. So otherwise, you could hand label. So you could hire people or get a group of people to sort of just label by hand. And this is quite cool because it's very customizable. I mean, if I'm looking for buildings to label buildings, then it's very easy like that. I can just find people, tell them what a building looks like, and then tell them that I want maybe a very tight wrapping around that building. This can be very expensive, and given that satellite images span huge area, then that means you might need a lot of people or a lot more days for this to happen. More on data hand labeling. You might find companies to do it for you if you have money for it. Otherwise, you can set it up yourself and sort of find volunteers to help you do it. So I think these slides will be made public. So these are some of the links to finding labelers or doing it yourself. So other big things to think about hand labeling include ways to evaluate the labels. I mean, people might be tired and just label however, or maybe they might not have understood you and they might label however. So you need another set of labelers to sort of evaluate the first labeler's labels. And just curating that whole administration can be a bit challenging, but then certain tools can help you sort of do that a lot more better. And yeah, just the curation process as well is another thing to think about. Just putting together the initial data set and then the overlaid labels and then the evaluated ones, and then storing the data set itself and securing it can be another thing that you need to think about, very important. And data version control. So I find that usually when you hand label, there's like a first batch that you hand label, and then you find out that it could be made better this way, that way. And then you have to move to a different version. And then maybe towards the end, you find that you have tuned things too much. Maybe you might need to go back to it like an earlier version. So having like sort of version control around that can be very, very helpful given that situation. So yeah, some other tools to consider is QGIS. So this is very important. It's open source, and it can allow you to view these spatial data sets, including satellite images and vector data. And then Python libraries to sort of help you with that. GDAL is a very big one. It can manipulate things from the image size, the spatial resolution. I mean, if you're trying to move from higher spatial resolution to a lower spatial resolution, then it's easy to do that. And these are the sort of modules. So my work was focusing on using satellite images to sort of classify neighborhoods. And a big chunk of that work included labeling these neighborhoods that I'm actually interested in studying. So I evaluated things from looking at the census data, the spatial data, which is provided as part of the census, which sort of just labeled that section of land as maybe suburb. But then one big problem was that the empty spaces were still labeled as suburb, and my model was very sensitive to that. So I had to iterate to maybe a more the cadastral data set, which is provided by the government as well. And so the data set just tells you who owns, like all the registered plots of land. So because it's registered, there's supposed to be houses here, but there are no houses here. So that was another area that I was not willing to compromise on, because people own land, plots of land, but then they might not be developed, and that might bring that brought a huge room for error when I was defining what a suburb sort of looks like. So I had to iterate back into finding out where the buildings are, and then labeling accordingly. So some key takeaways, finally, is that you need to understand that data labeling is an iterative process, and small technical things during this ground truth dataset creation include noting that JPEGs sort of compress and change the color value, whereas PNGs sort of reserve the original. If it's green, it doesn't, when it compresses, it doesn't change the green to 1 to 55:1. So JPEG sort of does that, and which could mess up, depending on what you want to use it for. If it's segmentation or instant segmentation, that could mess up your labels. OpenCV looks at BGR versus RGB maybe, and that could be another error that you might not be aware of. But yeah, data collection takes time, and you must be mindful that like as you're getting data from different companies, you must ask, if you're trying to use it for research, you must be able to ask whether they'll allow you to publish the data, or publish work done using the data, because it might be confidential. And that might limit what you use the data for. And also data exploration can be quite emotional. I mean, you see a lot of things on the ground, and maybe in the next few months or years, those things are no longer there. You just ask yourself what sort of happened during that transition. Well, thank you. Any questions?
Okay, thanks a lot, Raesetje, for that. While people are bringing up their questions, you can either raise your hand. You will be, then you can, once I then gesture to you, then you can unmute and ask your question. But then one question maybe that just to kick things off while we're doing this Q&A now is likely kind of some of the ethical considerations, especially when you're working with satellite imagery.
Yeah, sure. Absolutely. Yeah, actually, I've thought about this for a while. And I was just thinking, you can actually get the same satellite images from Google Maps, especially when you're working with things like neighborhood classifications or more aggregative kind of things. But then, however, another open question that still remains is that if you're looking at satellite images which are taken daily, is that really putting people under surveillance, and who should have access to data like that? Because there are satellite images which take images daily, but then regulations around, I think there should be tighter regulations around who gets access to that kind of data set, and sort of like an ethical clearance of some sort when working on projects of that nature.
All right, thanks. Emily, would you like to ask a question?
Hey there, thank you so much for your presentation. It's really early this side, so I might sound a bit groggy. So I just asked, how many already labeled data sets exist that you can then transfer to your own, for your own problem, for your own research, and to just generally other problems that might be interested in, like building classification and neighborhood classification?
Well, there are, depending on the type of task that you want to solve. If you are trying to maybe label buildings, for example, there are data sets such as Deep Learning. I can provide a list to Vukosi for him to publish, like already publicly available data sets and challenges, data set challenges, which are like there. Like Deep Globe, which has like 3 tracks. It has land use classification, land cover classification, which sort of looks at water bodies, residential area, roads, and things like that. And then one on roads specifically, and then one on buildings, like individual buildings in a section of land. But these are like in more developed, these are from developed countries. And yeah, and it's not a huge data set, but then if you are trying to sort of do transfer learning and you have a small data set that you've labeled already and are trying to get going with a model from that nature, I would start there. But yeah, I can provide you a list with publicly available data sets that I know. And you'll get it from Vukosi.
Thank you.
Okay, hi, thank you so much. And thank you so much for an excellent presentation as well. I was very pleased to see when you brought up QGIS. It's a wonderful tool. What I wanted to know from you personally, because QGIS's integration with Python is just so phenomenal. What was the silver bullet for you? So which package or which Git was the silver bullet for you in your research?
There actually wasn't like a single, because I was using QGIS for something else. Like I was viewing the images and I was doing like spatial intersections and joins, which was quick, like buffering or like, expanding points into polygons and things like that. That was really quick from QGIS. But then I used GDAL for manipulating spatial resolutions. I also used it to sort of convert from JPEG 2000 to GeoTIFF, but then mostly using Python and like, image libraries to sort of now create the masks themselves. So more on using this one called Raster as well, this library called Raster, which sort of helps you overlay shapefiles onto satellite images and then get a mask from there. And then from that, I could say all the parts which are not black or white, depending on what I set, those are neighborhoods. And then now I could label them into yellow, like township as yellow, informal settlement as red, and things like that. So it was more a combination of different things.
All right, thanks. Dina? Is Dina, can you ask your question? Okay. Okay, if she can't.
Thanks for the nice presentation. Yeah, thanks for the nice presentation, Raesetje. I just wanted to know, what are the good solutions for storage of such big data? That is the keyword. Yeah.
Yeah, so actually I started mine on hard drives, and I just found it a bit difficult, like, physical external hard drives. And I just found it a bit difficult to collaborate. to collaborate, like other people who are also trying to view the data and use it in the same project. So now I just sort of moved to more cloud solutions. In the past, I've used AWS, like I've just put the data on Amazon Cloud Services on a disk. Otherwise, like on a disk on GCP or in a bucket, that also works best, especially if you're looking at collaborative work.
Thank you,
Yeah.
Olubenga.
Yeah.
Can you ask your question, Olu? Okay, because if you can come on, I'll ask. It's just, how do you work around data collection considering the land issue in South Africa? He's currently working on crop yield forecasting using satellite images and data collection, and this has been a major challenge for him.
How do I work around the land use?
Sorry, data collection considering the land issue in South Africa.
Oh, okay. Yeah. Sure. Actually, one fun fact, not so fun, I suppose, but officially I couldn't find labels of townships anywhere. So labeling townships was just a chore as well, because townships and suburbs have been labeled as one thing called formal residential areas. And now you have to so I looked and I couldn't find spatial data sets of that nature. So I had to now embark on hand labeling and evaluating labels of township. So that was one big issue, which sort of stemmed from the whole post-Apartheid land issue things. But then it's actually very difficult to find such data sets. But then there are companies which sort of do this. I'll send Vukosi a list, but then they have you can't publish, some have you can't publish kind of clauses, and or you have to buy. Otherwise, the Department of Rural Development has one on building classification, but then that's only for buildings, like detecting buildings, but that's only for buildings which have been registered with them. So that's a bit difficult. However, I don't know. It's very difficult just navigating the government to sort of give you labels on things like where the water bodies are in South Africa. That can be a bit of a chore to sort of find. But then I had to keep on sending emails and going there myself and moving from person to person to sort of just find it. I suppose it's a bit difficult now with COVID, but that's sort of how you sort of get into it. However, you need to know people. But then as you are knocking on these doors and doing all these things, people know other people. And yeah, it's not like a lost journey.
Okay, thank you. Jade, do you want to ask your question?
Yes, thank you, Raesetje, for the awesome presentation. I have many questions, so I will pick one. How many kilometers did you eventually need to label? And were you finding it was predominantly hand labeling that you had to do, or was it what was the split of 70% was existing data sets and 30% was correcting those data sets? Sort of, what does it describe that?
Well, actually, there are, I think, 6,000 polygons. No, maybe 12,000 polygons of township in the country. And it was just more in the intermediary kind of labeling. I found names from internet sources, and then I sort of found people to sort of validate that that name is of a township, that sort of section is of a township, and then I was able to sort of match, because I had polygons with those names and I had satellite images. I had polygons with those names and also labels of whether or not they're township or suburb, or whatever. So now I could change that from those shapefiles and then translate it onto the satellite image masking. So yeah, I could say maybe like 30% of the labels. I had to sort of find people to sort of evaluate whether or not those are really townships.
And did that take 80% of the time?
No, actually, it didn't take a long time. I was at Wits where there were people from different parts of the country, and they could do that. Like I could just find people from the Eastern Cape, ask them if they know townships in the Eastern Cape, and then whether or not these are the names of the townships they know, find another person to sort of evaluate, things like that.
That's actually that's actually useful to have everyone so close by.
Yeah.
Otherwise, I'd imagine it would be impossible. Awesome, thank you.
Yeah. Yeah, otherwise it's like a difficult thing to do. But yeah.
All right, Hope, do you want to ask a question?
Thank you for a nice presentation. I would like to know how you managed to train your model while ignoring the background in the images.
Yeah, so because I had images of the whole country, like data that covers the whole country, I was able to just, count the pixels and say images, and then get like a ratio correct. Images with over 70 images where, so I firstly tiled the images. So from 21,000 pixels, I sort of just chopped them up and tiled them into 256 by 256. And then within each 256 by 256 image, I looked for images which had less than 70% of the pixels, where 70% of the pixels were not off background. And then I kept those images, and then I trained my model accordingly. Because otherwise, over like 70% of the country is of background pixels, or it's vacant land, none built up land. So that would have been difficult. And I still had like 700,000 images that I could salvage for my model, even after doing that task.
All right, thanks. Kelvin, can you ask your question? And I think it's also connected to Smash's question as well.
Hi, Raesetje. Thank you for a very cool presentation. Just wanted to know, in terms of your neighborhood classification for your master's work, which machine learning classifiers did you implement, and which one was found to perform the best through your research?
Yeah, sure. I actually looked at a couple, but then I used UNet, mainly because firstly, I didn't do localization or just classification. I did semantic segmentation. So I was labeling each and every pixel. So the classifier would have labeled each and every pixel. And for that, I used a UNet, which seemed to have like better results, given that I was training from scratch.
Cool, thank you.
I think the last question then will be from Kerry.
Hi, Raesetje.
Hey.
I'm going to put my video on because otherwise it feels weird. Hi, how are you?
Good, thanks. How are you?
Well, thank you. Cool. So awesome presentation. I always love this talk that you do. My question is about the Surveyor General. So I believe that they're responsible for updating the maps and like updating the boundaries between suburbs and stuff like that. And so I was wondering if that had an effect sort of at all in the work that you were doing? Like if a boundary between like one road changed, did that affect anything?
So actually, thanks for the source. I didn't know about Surveyor General. And that's sort of what we're doing for this paper that we're moving into publication. But then otherwise, I was just looking at 1 year of data. Okay. Yeah, so sort of just creating that pipeline because although that's like the bigger project that we are doing, creating that dataset pipeline was really important because it didn't exist before. So we spent a lot of time just creating that dataset, and this is just, yeah, that's just what we've done. But then now we're moving on to, we've moved on to looking at between the years and changes like that.
Okay, cool. Thank you.
All right. Thank you, Raesetje, I think, for that. It was very informative in more ways kind of than one in working in these areas. And I think not just talking for me, hopefully for also other people on the seminar, we do look forward to seeing more of this work in the future. I think it is very important because we are trying to understand our world more and more, and through us having different sensors, satellite images just being one of them, we can then work towards also changing some of the ways that we understand our world. It's the same as, like, you know, when you talk about what is this thing, income in South Africa. People have normally a very skewed view of what income actually is, and until you actually show how, like, you know, you start looking at the data and explaining what actually you're seeing through that data to people that understand what you mean when you say, like, you know, the median income in South Africa is almost 4,000 rand. And that's a crazy amount. But then even in this case, if you're looking at spatial spatial distribution and how it's actually being used in decision making, it's very important on there. For everybody else in this last minute, thank you for coming through today. This was our first one, and I think it was a good way to kick this off. There will be more. We'll try to announce the next speaker in the early next week. For example, please take time to, there's a link now that just got, you can just click on it to give feedback. It's very important to get the feedback just so that we can design this program in a good way that also reacts to kind of what the community, in terms of people who are interested in this, so that we can actually make sure people can have access to this. Very quickly, the video, we'll do some post-editing later. From here in the afternoon, I have back-to-back meetings after this. And then we'll make it available online, given Raesetje is like, you know, hey, she'll give a little tips and links and all those things. I think I will make sure that it's available also via a blog post on the group website, and it will have all these nice little notes given the questions, and then little links that people then can use from there. Thank you. Enjoy your Friday. Hopefully have, I don't know, your third cup of coffee. I'm about to go do that before I jump into the rest of the day. Thanks, everybody, and enjoy your day.
Thanks for Cozy.